Here we're going to evaluate the expression 2x plus 3, and let's say x equals 5. So what we have to do is we're going to take that 5, and wherever we see an x, we're going to replace it with 5. What I like to do is put a parentheses around that to help me organize myself. So I'm going to replace the x with 5. Then I have to multiply. 2 times 5, I get 10, plus 3, and I'll get 13. So this expression is equal to 13 when x is 5. Let's look at some more examples here. We're going to evaluate when x equals 3. So here's two separate examples. The one on the left, again, we're going to replace x with, in this case, 3. And I'm going to get 3 squared. And 3 squared is like 3 times 3. And 3 times 3 is 9. Let's look at the other one there. 5 to the x. We're going to replace the x with 3. And here I have to multiply the 5 times itself 3 times. And we get 5 times 5 will be 25. Those two right there. And then we still have another 5. And 25 times 5, like if we have 5 quarters, we get $1.25 or 125. Let's look at another example where we have a polynomial and we're going to replace x is 4 in this one. We're going to evaluate this expression with x equals 4. So here again, we're going to take that 4, and wherever we see an x, we're going to replace it with 4. And again, I like to use this structure of putting parentheses around it. Keep myself organized. And replace the x with 4 in both spots. Then we have to do the exponent here first. 4 squared. 4 times 4 will get 16. 2 will still be there. And we'll have negative 3 times 4 will get negative 12. And then the positive 5. And we get 2 times 16 will be 32. Minus the 12 plus the 5. 32 minus 12 will get 20. Plus 5, we get 25. Let's look at another example here. Here we already have it worked out. We have x equals 3, and again, we just plug them in. X equals 3 for each part. 3 squared, we get the 9. 4 times 3, we get 12. And we work that out right there. And we end up with 40. So that means that this expression is equal to 40 when x equals 3.